Hello everyone, my name is Nikita, and today I would like to show you how you can make your .NET application talk to a MongoDB server. First, we are going to take a look at how to create a Mongo client, then how to define a collection, then how to do some basic create, read, update, and delete operations. And in the end, we are going to take a look at some more complex examples, including the use of builders, bulk operations, and aggregate pipelines. Let's begin. For this example, you would need a .NET application. I'm using a simple console project template. You can see it on the left side. And you would need a MongoDB instance, for which I'm using an official Docker image. And you will be able to find all of this code on GitHub in the link under the video. Let's connect to the server and insert our first document. To do that, we would first need to install a MongoDB driver. You can do it with this command. It is installed. You can see it in your csproj file. And let's jump ahead. I'm going to show you how to create a client. Now we are in our program.cs file. As you can see, I've went ahead and wrote some lines. So we have our Mongo client. It accepts a connection string. Connection string is what you would expect. Your protocol, your credentials, host and port, and admin is authenticating database. It's not a database where we are going to write our records, our documents in. It's a database that contains our user credentials. Next, we define an instance of our database. Here we can specify its name. And on line 8, we create an instance of our collection that represents our collection. For now, I'm going to use bson documents, but we are going to change it pretty soon. And the name of that collection is going to be events. At this point, no requests, no connections were made to the database. This is all in memory of your application, and it can be registered as singletons in your DI container. Because it doesn't matter how many instances of clients you have, if all of those clients have the same connection string, the same settings, they're going to use the same connection pool behind the scenes. So you can safely register them as a singleton and reuse them wherever you want. Next, on line 10, we are going to do our first insert. I'm going to use a bson document just to show you what it is, how to work with it. Essentially, it's just a collection of key value pairs. We have a key ID with a value of ID. We have a key title with a value tet here and concert. Before I run this application, let's take a look at MongoDB Compass. As you can see, we still do not have our CIP MongoDB database here. And let's now run our application. .NET run. All done. Let's check Compass again. Refresh this. We got our database. We got events and our first event. And back to our application. As you can see, I've created a record called event. It's a little bit different from our bson document because now it also has date time, which is supposed to represent the starting time of the event. And worth mentioning here that it is expected that you have some property that is called either Pascal case ID, lowercase ID, or an ID with a preceding underscore. Now let's jump into program.cs. Here I changed bson document to event. I've created a new event with the same name, but now I've also added a date 1 week from now. Unfortunately, event is a reserved word, so I have to name it @event, but I'm committed now, so we are doing this. Now let's run our application. .NET run. Done. And let's go check our database. Refresh this, and we got one new event, now with starts at. Let's try to read it from the database. To read the record from the database, you can use this collection.find syntax. It expects an expression. If you've used entity framework, it's the same. You can do match by ID, you can do any property here, starts at, more than, and you can say like starts more than 1 week from now. And let's revert this. And here I'm returning first to default, but just as with the entity framework, you can do to list async. If you want to return multiple entities, it's up to you, up to your use case. So we create a record and we try to read it. Let's run this again. .NET run. And there it is. We've inserted that record and we've read that record. Now let's try to update it. Now you can see the update example. Here I am using the event that I've just read. I'm creating a copy of it with a new title. And I'm using replace one async method. If you are working in an entity kind of style, replace is going to be good enough for you. But there are also other methods like update one async. I'm going to show it in the next chapter about builders. But for now, let's stick to replace one async. Also, I want to mention there are methods like find one and delete, update, replace. Those find one methods will also return you the record before it was modified. So if you delete something, it's going to return that deleted record and then it's going to delete it. Okay, for now, replace one async. It also expects an expression and an updated event, and it's going to replace the entire document. Let's run it again. Replace results. One was replaced. Let's check our database. There it is. As you can see, I've run it multiple times and we can check it by ID 457. 457. So the record that we've inserted, that we've read and then updated is right here. Let's try to delete it. And this is how you do it. Here I'm using delete many method because I want to actually delete all of the records that I can find. You can also use delete one, but if multiple records match your expression, it's going to delete the first one and be done with it, leaving everything else in place. So I'm going to use delete many, and I'm going to create all of the events that are going to happen this month, within next month. Let's try to run it. All done. 4 records were deleted. And this record does not actually have a starting date, so it's here. Now let's take a look at the builders. But before doing that, I actually want to modify our events. I want them to have nested documents called tickets to better illustrate the benefits that builders provide. So I have created our tickets model. It has 2 properties, IDs and client. Client is just a string. It's supposed to be your client name. Like when you buy a ticket, it belongs to you. It's in your name. And events now have a list of tickets, just a list of tickets, nothing fancy. So let's create an event with some tickets. I actually have it prepared. Let's copy paste. I'm going to create an event with 2 tickets in the name of Dora the Explorer and Dora the Destroyer. Let's put a breakpoint here and actually run it in a debug mode. And on the right side, we can see, let's go to the next line actually. Read event. We can see the tickets. Let me expand it. And we can see 2 tickets. One for Dora the Explorer and one for Dora the Destroyer. And we can see them in the database as well. As you can see, it's nested. It's all fine. It's all good. We can let it run to completion. Okay. And now, let's say we made a mistake. We created 2 tickets for the same person. And we actually meant to have, for this third person, to have a different name. How can we update just this one ticket? With the previous replace syntax, we would have to resend the entire event with all of its tickets. And it's less than optimal if you have, like say, hundreds of tickets. It's a lot of data, it's a lot of traffic, you don't want to do that. You ideally want to just update that one field on that one nested object in this array. So only like this field, only here, without sending everything else. And here, builders can help you. So let's see how you can do it. Here I replaced the update code. As you can see now we have filter.end. This means that both of these conditions should be true. First condition says that event ID should be equal to event ID that we've already inserted. The second condition says that tickets elements should match this condition. This condition says that client name should be Dora the Destroyer. So this filter is going to match both of these tickets on the event that we've created before. Now, Before, we were replacing the entire event, so we were sending the whole event with all of its tickets. But now we want to actually just set the client name on one ticket. So we use this update builder. Here it says that tickets -1 means match the expression. So tickets that match the expression set client to Dora the pacifist. And now finally we use update one. Before it was replace one, now it's update one. If we use update many, because we have multiple tickets that match this filter, it's going to update all of those tickets, but we only need to fix one of them. So this is why I use update one async. So we apply the filter, we apply the update, and we wait for the results. Let's actually run it in debug mode again. Okay, it's here. I'm not going to use the debugger here. Actually, I just need the breakpoint. So right now we are in a state before update. Let's check the compass. Tickets. We have 3 tickets and we have 2 Dora the destroyers. Let's jump to the next line, to the next breakpoint. And now let's refresh the database. As you can see, the first one that was found, that was Dora the Destroyer before, now it's Dora the Pacifist. So we've updated one nested record without resending the entire event. And now we are going to take a look at how we can make multiple operations in one request. So using this write model array, we can define those multiple operations. First one is going to be insert. So I'm going to insert a new event, which is going to be called 50 pesos concert. And the next one, I think I'm going to do a replace. Yes, let me copy paste it. Here it is. So it's the same update that we had before. We are using our inserted event and we are changing the title from Ted Hiran to Taylor's Law. And now we are going to use our trusted collection reference, and it has a method bulk write async where we pass our models. Let's run it in a debug mode. Here we are, right before our bulk write operation. Let's refresh the database. We have our one Ted Hiran concert. So we jump to the next line, our bulk operations went through. Let's refresh our database again. So our Ted Hiran concert turned into Taylor's Law concert, and we added a new 50 pesos concert. That's it, that's the power of bulk operations. Let's see what we can do with aggregate pipeline. Aggregate operations are never easy. Almost every time you use them, you will have to use BSON documents in the end, so you will lose your type safety. And they are complicated and varied, so I'm going to show you one example here, but I can guarantee you that you would have to go to the documentation and adapt it to your use case. So here in this case, let's imagine you have a real event with thousands of tickets, and you need to display those tickets somewhere in the admin page, so you need pagination. Let's say you want to display, well, here it's 2 tickets per page. How would you do that? You first would need to unwind your tickets, and unwind is also a bit hard to explain. Essentially, it's going to create a new event for every ticket, and in those new created events, it's going to replace the tickets array with the actual ticket for which this event instance was created. So if you had 3 tickets, you will get 3 events with 1 ticket in each. And here I'm going to skip one of those events, and I'm going to take the next 2. Next operation is group. So it's kind of the reverse operation to unwind. So I'm pushing all of those tickets back into array. And the next operation is project, where I'm telling the MongoDB that I only need to receive those tickets from the request and nothing else. And here I'm going to do first async because I only have one event and tickets for it. So I only need this one event, this one object. This is actually a BSON document, so we lost all of our type safety, all of our type knowledge. Compiler doesn't know what it is. It's a BSON document right now. But we know what it is. And what we can do is we take that events aggregate. We know that that it has one property called tickets. We can get it. We can say that it's bson array, and bson array is enumerable, so we can use link on it, and we can select tickets. And again, because we know what those properties are and what their names are, we can actually take them and map them. And this way we can actually get our in-memory tickets, our tickets models, and we can map them to list. Let's also do console write here, and let's run it. So we found 2 tickets instead of 3 tickets. That's totally fine. This is what we wanted because we have a page of 2, and we have this tickets variable, 1 ticket for Dora the Destroyer and another ticket for Dora the Destroyer. This is fine because we did this aggregate replace, and we replaced it with not updated event in our memory. So we actually replaced all of the nested tickets in there, and this is exactly the result that I was expecting. This is all with aggregate. This is how you can use it. I will link aggregate documentation in the description. And I want to quickly show you how you can create an index on your collection. So it's going to be an asynchronous operation. So await collection indexes, create one async, and we need a new create index model for the event. Yes. Now it requires a builders event index keys. Here you can select index type. For me it's going to be text because I want to index title property. And here I can provide an expression that will select the property that's going to be indexed. Let's align this a little bit. And this is it. This is how you create an index on your collection. You can safely run it every time with the start of your application. If the index already exists, nothing is going to happen. I was trying to make this video shorter than the previous one. I hope I did not skip anything important and that it was still useful to you. If it was, then please leave a like and subscribe. And if you have any questions or feedback, feel free to leave a comment. Any feedback is appreciated. And again, this code is going to be in GitHub. All of the links are in the description. That's it. Have a good day. Bye.